In this lesson, we will solve the equation x to the fourth equals, open parenthesis, 5 minus x, close parenthesis, to the fourth. We will proceed step by step, and we will also build an intuitive picture of why the answer makes sense. Step 1. Take the square root of both sides to reduce the fourth power to a second power. This gives the square root of x to the fourth equals the square root of, open parenthesis, 5 minus x, close parenthesis, to the fourth. So we get x squared equals, open parenthesis, 5 minus x, close parenthesis, squared. Step 2. Take the square root again. Remember, the square root of a square gives an absolute value. So we get absolute value of x equals absolute value of 5 minus x. This means two possibilities. Case 1, x equals 5 minus x. Case 2, x equals the negative of 5 minus x. Let us solve case 1. X equals 5 minus x. Add x to both sides to get 2x equals 5. Divide by 2 to get x equals 5 over 2, that is 2.5. Now case 2, x equals negative, open parenthesis, 5 minus x, close parenthesis. Distribute the negative to get x equals negative 5 plus x. Subtract x from both sides. We obtain 0 equals negative 5, which is impossible. So case 2 gives no solution. Here is the intuition. Absolute value of x equals absolute value of 5 minus x means the distance from x to 0 equals the distance from x to 5. On a number line, the point equidistant from 0 and 5 is the midpoint at 2.5. Therefore, the only real solution is x equals 5 over 2, which is 2.5. Bonus note for completeness. Because fourth powers are involved, over the complex numbers we may also have solutions from the fourth roots of unity. Besides x equals 2.5, there are two complex solutions, 2.5 plus 2.5i and 2.5 minus 2.5i. Summary. We reduced the equation with two square roots, recognized the absolute value relationship split into two cases, and concluded the unique real solution x equals 2.5. We are given that x plus 1 over x equals 3, and we want x to the fifth plus 1 over x to the fifth. We'll build up powers step by step. First the square, then the cube, and then combine them to get the fifth power. Let's write the given equation and the target clearly. Step 1. Square both sides. We square x plus 1 over x and also square 3. Expanding the left side gives x squared plus 2 plus 1 over x squared equals 9. Subtract 2 from both sides. So x squared plus 1 over x squared equals 7. Step 2. Cube both sides. We cube x plus 1 over x and also cube 3. Using the identity that equals x cubed plus 1 over x cubed plus 3 times x plus 1 over x equals 27. Substitute x plus 1 over x equals 3. Now it becomes x cubed plus 1 over x cubed plus 9 equals 27. Subtract 9 to get x cubed plus 1 over x cubed equals 18. Step 3. Combine the results to reach the fifth power. Multiply x squared plus 1 over x squared and x cubed plus 1 over x cubed. On the right side, multiply 7 times 18. Expanding the left gives x to the fifth plus x plus 1 over x plus 1 over x to the fifth. Group as x to the fifth plus 1 over x to the fifth plus x plus 1 over x. Substitute x plus 1 over x equals 3. Then solve for x to the fifth plus 1 over x to the fifth. Therefore, x to the fifth plus 1 over x to the fifth equals 123. This power building approach is quick, avoids solving for x, and keeps the algebra clean. Let's solve the equation. 5 plus x over x plus 5 equals 5. We'll go step by step, keeping everything simple and clear. Step 1. Use the commutative property of addition. A plus b equals b plus a. That means 5 plus x is the same as x plus 5. Step 2. Because the top and bottom are the same expression, the fraction equals 1 as long as the denominator is not 0. The denominator x plus 5 cannot be 0, so x is not equal to negative 5. So the left side becomes 1. Step 3. Substitute this into the original equation. 1 equals 5. This is a contradiction, so no value of x can make it true while keeping the denominator non-zero. Cross-check. If we cross-multiply the original equation, 5 plus x equals 5 times x plus 5. That simplifies to 5 plus x equals 5x plus 25. Then 0 equals 4x plus 20, so x equals negative 5. But x equals negative 5 makes the denominator 0, so it is not allowed. Conclusion. There is no solution for x. Every allowable x makes the left side equal 1, which cannot equal 5. In this lesson, we'll solve the equation 4 to the x plus 4 to the x equals 80 step by step. We'll start by writing the problem clearly on the screen. Step 1. Combine like terms. Both terms on the left are the same, 4 to the x, so adding them gives 2 times 4 to the x. So we write 2 times 4 to the x equals 80. Step 2. Isolate the exponential term. Divide both sides by 2. That gives 4 to the x equals 40. Step 3. Apply logarithms to solve for the exponent. We take the common logarithm, base 10, of both sides. So we write log of 4 to the x equals log of 40. Step 4. Use the power rule for logarithms. The exponent comes down in front. That gives x times log of 4 equals log of 40. Step 5. Isolate x. Divide both sides by log of 4. We get x equals log of 40 divided by log of 4. Step 6. Compute the value. Using a calculator, log base 10 of 40 divided by log base 10 of 4 gives approximately 2.661. So x is about 2.661. For intuition, let's see where the graph of y equals 4 to the x crosses y equals 40. We'll draw axes and the exponential curve. Then we draw a horizontal line at y equals 40. Their intersection occurs at x approximately equal to our answer. To recap, we combined like terms, isolated the exponential, used logarithms and the power rule, and solved for x. The solution is x equals log 40 over log 4, approximately 2.661. In this lesson, we will solve the equation, the fraction with numerator x to the 6 plus x to the 4 plus x squared over the denominator x to the 5 plus x to the 4 plus x cubed equals 87 over 29. We will go step by step, and we will not skip any steps. Step 1. Simplify the right-hand side. We check if 87 is divisible by 29. Yes, because 29 times 3 equals 87. Therefore, the right-hand side simplifies to 3. Step 2. Factor common powers of x from the numerator and denominator. In the numerator, factor out x squared. In the denominator, factor out x cubed. Step 3. Factor x to the 4 plus x squared plus 1 using a useful identity. We write it as the square of x squared plus 1 minus x squared. That is a difference of squares, which factors as x squared minus x plus 1 times x squared plus x plus 1. Step 4. Substitute this factorization back into the fraction and simplify. We can cancel the common factor x squared plus x plus 1 in the numerator and denominator, provided the denominator is not 0. Since we started from the given equation, we assume the denominator is non-zero. After canceling and simplifying x squared over x cubed to 1 over x, we get the expression x squared minus x plus 1 over x equals 3. Step 5. Split the fraction and collect like terms. X squared over x minus x over x plus 1 over x equals 3, which simplifies to x minus 1 plus 1 over x equals 3. Add 1 to both sides to get x plus 1 over x equals 4. Step 6. Multiply both sides by x, keeping in mind x is not 0 because it was in a denominator earlier. We get x squared plus 1 equals 4x. Move all terms to one side to form a quadratic x squared minus 4x plus 1 equals 0. Step 7. Substitute a equals 1, b equals -4, and c equals 1 into the quadratic formula. We get x equals the fraction with numerator 4 plus or minus the square root of 16 minus 4 over denominator 2. 16 minus 4 is 12. The square root of 12 is 2 times the square root of 3. So x equals 4 plus or minus 2 root 3 all over 2, which simplifies to x equals 2 plus or minus root 3. Therefore, the solutions are 2 plus root 3 and 2 minus root 3. We are going to simplify the fraction. The square root of 45 plus the square root of 15 over the square root of 45 minus the square root of 15. Our plan is simplify the radicals, factor what we can, and then rationalize the denominator with a conjugate. Step 1. Simplify the square roots. 45 factors as 9 times 5. So the square root of 45 is the square root of 9 times 5, which is 3 times the square root of 5. 15 is 3 times 5. It has no perfect square factor, so we keep it as the square root of 15. But it helps to remember it equals the square root of 3 times the square root of 5. Now rewrite the original fraction using these simplifications. We get 3 root 5 plus root 15 in the numerator and 3 root 5 minus root 15 in the denominator. Step 2. Factor out the common root 5. Notice that root 15 equals root 3 times root 5, so each line has a factor of root 5. Factor it out from the top and from the bottom. The root 5 cancels, leaving the simpler fraction 3 plus root 3 over 3 minus root 3. Step 3. Rationalize the denominator by multiplying by the conjugate. The conjugate of 3 minus root 3 is 3 plus root 3. Multiply the fraction by 3 plus root 3 over 3 plus root 3. Now expand. Start with the numerator. 3 plus root 3 times 3 plus root 3 equals 9 plus 3 root 3 plus 3 root 3 plus 3. Combine like terms to get 12 plus 6 root 3. For the denominator, use the difference of squares. 3 minus root 3 times 3 plus root 3 equals 3 squared minus the square of root 3, which is 9 minus 3, or 6. Putting those together, we get 12 plus 6 root 3 all over 6. Finally, divide each term in the numerator by 6. That gives 12 over 6 plus 6 root 3 over 6, which simplifies to 2 plus root 3. So the final answer is 2 plus root 3. Recap. Simplify radicals, factor common terms, cancel, rationalize with the conjugate, then simplify. The result is 2 plus root 3. Let's solve the exponential equation. 9 to the x minus 6 to the x equals 4 to the x. We'll turn it into a simple quadratic using a clever substitution. Step 1. Divide every term by 4 to the x. This uses the rule a to the x divided by b to the x equals parentheses over b parentheses to the x. After dividing, we get parentheses 9 over 4 parentheses to the x minus parentheses 6 over 4 parentheses to the x equals 1. Step 2. Simplify the fractions. 9 over 4 equals the square of 3 over 2. 6 over 4 simplifies to 3 over 2. Substituting these in gives parentheses 3 over 2 squared parentheses to the x minus parentheses 3 over 2 parentheses to the x equals 1. Using the power rule, that becomes parentheses 3 over 2 to the x squared minus 3 over 2 to the x equals 1. Step 3. Make a substitution. To turn this into a quadratic, let y equal 3 over 2 to the x. Then our equation becomes y squared minus y equals 1. Move the 1 to the left to get standard form. Y squared minus y minus 1 equals 0. Step 4. Solve the quadratic using the quadratic formula. That gives y equals 1 plus or minus square root of 5, all over 2. Exponential values are always positive, so we discard the negative root. We keep y equals 1 plus square root of 5 over 2, the golden ratio. Step 5. Back substitute. Y equals 3 over 2 to the x. So 3 over 2 to the x equals 1 plus square root of 5 over 2. Take natural logs of both sides and solve for x. X equals natural log of parentheses 1 plus square root of 5 over 2 parentheses divided by natural log of 3 halves. Numerically, this is approximately 1.186. Recap. We divided by 4 to the x, simplified to a quadratic in y, solved the quadratic, kept the positive root, and used logarithms to isolate x. Our final answer is the exact expression and its decimal approximation. We will find all integer solutions to the equation a plus b equals 2ab minus 127. We will use Simon's favorite factoring trick. First, write the problem clearly, then rearrange to collect a and b terms together. Because we want a clean product that looks like 2a minus 1 times 2b minus 1, multiply both sides by 2. That gives 4ab minus 2a minus 2b equals 254. Notice if we add 1 to the left side, it becomes a perfect product. So we add 1 to both sides. Now it factors as open parenthesis 2a minus 1 close parenthesis times open parenthesis 2b minus 1 close parenthesis equals 255. Now we list factor pairs of 255. 255 factors as 3 times 5 times 17. We consider positive and negative pairs because the product must be 255. For each factor pair x and y, with x times y equals 255, set 2a minus 1 equals x and 2b minus 1 equals y. Then, at equals x plus 1 over 2 and b equals y plus 1 over 2. Because 2a minus 1 and 2b minus 1 are odd, every listed x and y produce integer, a and b. Let us compute the solutions. We convert each pair x, y into a equals x plus 1 over 2, and b equals y plus 1 over 2. Here are all 16 integer solutions, including both orders. Summary. Rearrange to 2ab minus a minus b equals 127. Multiply by 2 and add 1 to complete the product. Factor to 2a minus 1 times 2b minus 1 equals 255. Then map factor pairs to find all integer solutions. We're going to solve this equation step by step with no gaps. The equation is 4 to the x times 4 to the x times 4 to the x divided by 4 to the x plus 4 to the x equals 40. Step 1. Simplify the numerator and the denominator separately. The numerator is 4 to the x times 4 to the x times 4 to the x. Same base multiplied means add exponents. That becomes 4 to the 3x. The denominator is 4 to the x plus 4 to the x. Adding the same term twice is 2 times 4 to the x. Now, we rewrite the whole equation using those simplifications. We get 4 to the 3x over 2 times 4 to the x equals 40. Divide same base powers. Subtract exponents, so 4 to the 3x divided by 4 to the x becomes 4 to the 2x. That leaves 1/2 times 4 to the 2x equals 40. Next, isolate the exponential. Multiply both sides by 2 to remove the 1/2. Now solve for x using logarithms. Take the logarithm of both sides. log of 4 to the 2x equals log of 80. Bring the exponent down. 2x times log of 4 equals log of 80. Divide both sides by 2 times log of 4 to get x. As a quick check, we can rewrite with base 2. 4 is 2 squared, so 4 to the 2x is 2 to the 4x. 80 is 16 times 5, or 2 to the 4 times 5. So 2 to the 4x equals 2 to the 4 times 5 gives 4x equals 4 plus log base 2 of 5, and x equals 1 plus 1/4 times log base 2 of 5. Finally, compute a decimal approximation. Using common logs to 4 decimal places, x is approximately 1.58. Summary: we simplified the fraction using exponent rules, isolated the exponential, and solved with logarithms. Answer x is approximately 1.58, and exactly x equals log of 80 over 2 times log of 4. We will solve for positive integers a and b in the equation 1 over a plus 1 over b plus 1 over a, b equals 1 over 4. We'll proceed step by step. Find a common denominator, cross-multiply, use Simon's favorite factoring trick, and list the factor pairs to get all solutions. Step 1. Use the common denominator, ab, for all 3 fractions. That gives b over a, b plus over a, b plus 1 over a, b equals 1 over 4. Combine the numerators to get a plus b plus 1 over a, b equals 1 over 4. Step 2. Cross-multiply to clear the fractions. For times the quantity a plus b plus 1 equals ab. Expanding gives 4a plus 4b plus 4 equals ab. Step 3. Rearrange to put all terms with a and b on one side. a, b minus 4 a minus. Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple. One video at a time, only on muyversemaths.